Now in this problem video, I want you to start and see if you can answer it right now. Think about it for a few seconds, pause with the video paused, and if you're really stuck, hit play for another couple seconds and I'll give a hint. Okay, so the hint here is an approach. First, figure out how many moles of each we have and how many are used if we run the reaction. And to do that, we're going to pick one reactant. We'll choose one product to make. Either one's fine, but if you see there's a part 2 to a problem, you'll want to pick that one probably because it'll save you some extra math in part 2. Now, you're going to calculate how many moles of that product you can make. Then you're going to switch over to the other product to see which one you can make, and whichever one makes the least amount is the one you ran out of first. Now go ahead and pause the video and try this problem. Okay, I'm going to give myself some more room by getting rid of that hint. Okay, so if we have 155 grams of HCl, and we had 21.11 gram of aluminum, we're going to see which one is our limiting reactant. Now, in that problem, I'm going to set up a fence post right here. I'm going to convert from grams into moles for HCl. The next thing I need to do is go from moles of HCl into moles of one of my products. Now, I'm going to choose aluminum trichloride. You could have picked anything on the product side here, but I'm just going to choose that one. You'll also see that other places you might see a video that tells you to convert from one into the other and then compare the numbers. You can do that, but it gets a little bit complicated because you have two different spots with the same thing written down, and it's very easy to make a mistake and grab the wrong number and move forward with it. So I don't encourage you to do that. It's not incorrect to do so. It's not physically wrong to do so. It's just a problem for organization, and I see a lot of people get problems wrong because they've accidentally used the wrong number in the second half of a problem. So I encourage you, pick something on the other side, like the products over here. All right, so I had 6 moles of HCl, and they're forming 2 moles of aluminum trichloride. I'll put in my molar mass in just a second. So I'm in moles of AlCl3. I don't need to go to grams. I can stop right there. If I know the next step is to go to grams, I could also just do it right now, but I'm just going to solve it into moles. Now, what I also need is I need my molar mass of HCl. So for that, we're going to have 1.008 for the mass of hydrogen. We're going to have 35.45 for the mass of chlorine. We're going to add those down. We'll have 8, 5, 4, 6, 3. We'll chop it off right there. Now what I'm going to do to make sure that I don't have any round off error early is I'm going to leave this as an insignificant figure. So I'll write it as 36.458. And when you drop cap like that, it means that it's not significant, that you should have rounded it to be 0.46, but you're not going to do that until later so you don't have any rounding errors. So that many grams per mole. I encourage you to use the fence posts instead of just setting this up as a multiplication problem, because people will constantly forget that they're dividing by the grams per mole, and so they'll multiply it and instead they'll have some very large number. This prevents you from having that issue pop up. So what we'll need is a calculator where I can type in my 155 divided by my 36.458 times 2 divided by 6. And I get 1.417. Now I've got 3 sig figs, 4 sig figs, exact. So I'm limited to 3 sig figs. My final answer there will be 1.42. 1.42 moles of my AlCl3. Okay, now let me get a quick reality check for that, and let me also fix my handwriting. Okay, there we go. Now our reality check is to say, well, I had 155 grams. You know, I'm expecting that's going to be something like 4 moles when I divide by that. So 4, and then I'm going to divide by 6, multiplied by 2. So that's taking about 1/3 of 4. And this is going to be about 1/3 of 4. So just giving a very fast reality check to make sure I didn't screw up on the calculator. That looks reasonable. Now we're going to set up a similar process down here for our grams of aluminum. Now, first thing I need to do is get from grams of Al into moles of Al. Next up, I'm going to convert from moles of aluminum into my moles of AlCl3. Now suppose that I had converted into moles of HCl. You see where that confusion might start popping up now? I'd be calculating my moles of HCl, I'd be comparing it to moles of HCl right up here, and that could get very confusing very quickly. For the cost of 1 extra conversion factor, which doesn't take any extra time really, I prevent that from happening. All right, so I'm going to set up my stoichiometry here. I had 2 moles of aluminum for every 2 moles of AlCl3. So that one's reasonably painless. Now we just need the molar mass of aluminum, which is 26.98. 26.98 grams per mole. I'm in moles. I'm set. So let's check our cross-canceling. That's all cross-canceled. Moles of aluminum, cross-canceled. Moles of AlCl3. That's right where I need to be. So let's grab that calculator again. Okay, so we'll have our 21.11 divided by 26.98 times 2 divided by 2. Just for form's sake, I'll even type it in, even though we know that's not going to have any impact. I'm going to be able to make 0.782. Notice 4 sig figs, 4 sig figs. Oh, so I need to go further. 0.7824. 7824 moles of AlCl3. So clearly, I'm going to run out of aluminum before I run out of HCl. In fact, I have about twice as much aluminum trichloride being formed from HCl as I did from my aluminum metal. So aluminum metal is going to be my limiting reactant. Now, of course, we write that out. I'm going to just abbreviate it as limiting reactant because I'm being lazy about writing. So aluminum is my limiting reactant for this one. Do we have anything else being asked for in the problem? No, so we're all set.